All right, good evening, everyone. This is Astro 10. My name is Celso Batalha, and I am teaching this summer online class of astronomy. And I have a few brave students participating in this chat room. That's fantastic. That's really historical. Yeah, two students. That's wonderful. Um, as I mentioned previously, I would like to take this chat room sometimes here and there, and and uh, and come up with some exciting ideas so that you can help and participate in the chat room. I mean, the chat room is when we get together as a family. If you think the classroom is in fact, let me put the camera here. It's kind of a just a second. Can I put the camera? Yes, I can. There you go. So the classroom is, for instance, this morning I had a physics course that I taught, two sections, and then so I have the students, we interact in the live, so it's a different ball game. And when I go to my online class, it's kind of a me and you guys there, kind of a distance. And when we have exams, I have to ask you guys to bring your identification because I don't know who the hell you guys are, and and so we don't know each other. So online have this has this type of problem that we don't know one another, and we so you guys are capable of learning by yourselves. So you are a self-learner, and as a result, you don't need so much the guidance of a professor. But that sense of family and learning from one another is gone in an online setting, and I like a lot if you guys could participate as much as possible in the chat room, even if you can log in later, just to check it out, see what's going on. Like in the case of a face-to-face setting, would be the equivalent of going to the classroom, check it out, see what's going on, and okay, can I go to the bathroom? And then you leave, and then you come back later. So you can do that online with more efficiency. Um, so extra credit, extra credit. So at the end of this chat room, or in the middle of this chat room, I'm not going to be easy and say where. I will ask you to let me know the answer of a question that I will pop up, and that is an extra credit. So the extra credit, like the other ones, right? So equivalent of I don't know, 1 point or 2 points or so, whatever that is. So I will upload today the exercise, but the question is gonna come up later, and only two of you will know the question in a few minutes. But the other one, I had to go to the trouble of reading and watching the chat room. Anyways, that's my little trick to get you guys together. Anyways, I like to initiate this chat room always telling you and warning you about what's going on and what you need to do. So if you go to the modules in Canvas, and I know few of our students, they still can't navigate easily through Canvas, and this is a big problem if you have to do online classes. And I have students that have full-time work, and when they get home, they have a full-time work at home with family members and so on, so on, so on, and that's why they sign up for online class. So usually online classes, rather than be something easy for the professor, has to be set in such a way that it's easy for you to find everything you need quickly, right? Because uh, these students need to pass the class, first of all. They need to learn, but they also don't have a lot of time. So having that in mind, which assignments are going to close? Homework number 1, close on June 25th. Multiple choice questions. Most of the questions have to do with scientific method. So you can maybe explore or ask me questions about scientific method. But the scientific method is the way science build up and create knowledge. For instance, knowledge in religions in general are built upon inspiration. So somebody have a great vision of something, and then communicate that vision to others, and if more so that vision came from some super being, that becomes very important, and that becomes law. In the case of science, there is a method by which knowledge is created. And so first and foremost, you have to observe nature. So you observe nature, see how nature behaves. In fact, science is, and I like to say that, it's like a window that you use to look outside and see what's going on outside, and then you observe regularities. And these regularities, this cyclic behavior, indicate some underlying law governing whatever is responsible for bringing this cycle into place. So once you observe regularity, like in astronomy, we have so many. We have the regularity of eclipses, big chunk of information in chapter 2. We have the regularity of day and night, simple one. We have the regularity of seasons. We have the regularity of certain constellations that appear in the sky at certain months of the year, and they are not there anymore in other months. Regularity of moon's phase, the regularity of sun's activity, the regularity of I can't remember, but seeing Milky Way at certain configuration throughout the year. So all this cyclic behavior indicates some underlying laws. And then what astronomers do, or physicists do, or scientists do, is to determine what laws are. What are the laws of nature? So if I hold something in my hand and let it go, it's gonna fall. If I do it again, it's gonna fall, and again, it's gonna fall. So there is a law there that is governing the behavior of this ruler that keeps falling every time that I let it go. So you can explain these laws with some theory. That's how it goes. So you observe the laws, and then you create hypotheses to explain how that thing works. So this hypothesis might be checked, and that's what we do in science. So in science, you cannot create hypotheses using elements in your arguments that cannot be verified. So checks and balances are pretty much part of what we do when we build knowledge. And so once your hypothesis is checked and is based on a narrative that can be verified, for instance, I cannot say that this ruler is falling because there is an invisible angel that is pulling it down. Although I could say that prior to 1600, but the problem is I don't know what an angel is. I cannot describe what an angel is. I cannot summon the angel to a laboratory to measure its intrinsic properties. So I cannot use the angel as an argument in the narrative because I cannot verify that. So once you have elements in your narrative that can be verified, then you have a valid hypothesis. And then you check this hypothesis with all kind of um, uh, um, um, experimentations, with all kind of testings, and you might end up organizing this hypothesis in such a complex way that you call it a theory. So once you have a theory, the theory must be able to explain every single behavior associated with that phenomena. Has to be able to explain all available data associated with that phenomenon. But a good theory nowadays is able to predict events that you haven't observed yet. And this is the good thing of science. And very few people can grasp that importance. And I give an example. The example of how um, Uranus was discovered. So Uranus was discovered, the planet, as a result of some disturbances in Saturn's orbit. So you have a theory associated with that disturbances, theory of gravitation. So you have a gravitational force that planets exert on another and on the sun. And if you take that theory and you apply to the orbit of planets, you realize that um, Uranus orbit is being Saturn orbit was being disrupted by some unseen element, by some unseen object. So then somebody calculate and say, well, that object could be a planet, could have certain mass, could be at certain position in the sky to produce these disturbances. And voila, you point the telescope to that region and do a little scan and then you find the telescope. And that gives credence to the gravitational law. So that's the idea of science. Um, you see that again when Einstein come up with his theory of relativity and was able uh, to predict um, uh, uh, the bending of starlight in the presence of the gravitational well of the sun that was not being predicted by existing theories, Newtonian theory. And once conditions were met that such a bending could be observed, so theory of relativity proposed by Einstein became pretty much important. So scientific theories depend on nature. They do not depend on us. So we don't create the theories as a statement of truth. I mean, we observe nature, we try to interpret how nature behaves, we create the theories. The theories predict things that we don't know. So you create technology, and you collect money like the LIGO um, observatory to measure gravitational waves of colliding black holes, like was predicted early in last century, and it takes several years when to the point that you have the technology that you can measure these things, and then you create the technology, you measure with such a precision that say, okay, that theory is very good because predict something our biases was not suggesting to exist. Um, in a way, when I say that, I'm also saying that science is not the same thing as religion. In religion, you have a set of statements you cannot change. So if you change, you are not talking about that particular religion anymore. You are talking about some other religion. So we cannot change that. It's pretty much stationary. It's kind of a fixed. So in science, we have these theories. As long as they are good to explain what we observe, we use them. But maybe 10, 20, 30, 50 years from now, some of the theories that now we use to explain behavior, they will become inadequate to explain some other behaviors that technology was able to bring about. And then what you do, you have to create some mega theory that can incorporate this new data, right? This new data in the future, but also be consistent with everything we know up to that moment. So in a way, science is evolutionary, is something that is always grow, which makes science something very exciting. So homework number one is focus a lot not only in the elements of our universe, but also the scientific method. We have a group discussion about my cultural background, and I start reading today, and I haven't graded yet, but I read a bunch, and I put grades today. But most of you are not following the guidelines. So the guidelines are, I don't want you just to go there and say, well, because in my religion, there is in such a place, there is some reference about the moon and the sun and the interplay of those and my grandma. So you have to go to your religious book if you are a religious person or if you have a religion. Go to your religious book and quote the passage, the phrase that specify a specific astronomical event, like an eclipse, or that specify or comment on the existence of moon and sun or the universe, how things appear, things like that. So bring not your interpretation, because I know it's great. I mean, I feel happy to hear, but that's not the point of this discussion. You have to bring the quote, the sentence, and then in a further in a next step would be to determine how that astronomical object, usually the sun or the moon or planets or stars in general, or constellations, how those elements somehow found a way to be blended with the values and the moral values of a community in the past, becoming part of their moral code. So you can see that a lot in astrology. So if you go to Mesopotamian astrology, which was a system based on the fact that um, the sun visits certain groups or stars throughout the year. So they are called constellations of zodiac. And by doing so, the sun, which was considered a god, as it visits these regions with the stars, also considered gods and with properties, would be able to rule the behavior of people. So if you go in India or China, you have the same idea, except the sun is not the issue, it's the moon. So you have the moon going to certain regions in the sky, 20 or 20, 27, if I'm not mistaken, nakshatras or houses, and every time the moon visits one of them, and the moon is a god, according to this belief system, and highlights certain characteristics. So the question is how the celestial objects, which have properties you are going to learn in this course. Again, this course is not a course about religion or mythology or anything, it's about scientific knowledge. How the physical properties of these objects, as we observe, as we see, ended up find its way to a culture and became blended with the moral values of that particular culture. This is the fun thing that is part of what we call archaeoastronomy. And then now in June 2021, which is today, right, June 20, we are, you have to keep going with the discussion, but primarily start to work on homework number 2. So let's take a look at homework number 2. Oh, sorry. So the shortest day of the year for a person living in the southern hemisphere is the what? So then we are talking about seasons. This is one important component of this chapter. So we know the Earth goes through three major motions. Is the daily or diurnal motion, Earth rotation. You should start reading this. So Earth rotates on its axis of rotation, and that's why we experience day and night, day and night. So this, my hand is the sun. This is Earth. Earth rotates. So this the back, the back of this ruler face the sun is daytime for the back, and then 6 hours later, the back of this ruler case is facing the night sky. So midnight for it. So because of sun's rotation, we have day and night. But in addition to that, Earth also goes around the sun in what we call yearly revolution. And because of that, and because we have tilt in Earth axis of rotation, we experience seasons. And seasons in the north hemisphere are reversed in the southern hemisphere. Let me see if I can show you why. There is a very cool animation that helps this a lot. Show you that. Why is it not coming? Safari, what's going on? Try another browser. Oh, the flash in my other browser might be, my flash might be outdated. That's why it's not coming. Okay. So let's look at Earth rotation. It would be nice if I could reduce this. So if I start animation, and what you see with this down here. Oops. So as Earth rotates on its axis of rotation, right? We note this axis of rotation, it has some inclination with respect to our horizon, and the reason is we are at different latitudes on Earth. For instance, if I stop here, pause animation. Nice if I could expand that. If I pause the animation, so it's kind of in the middle of the United States right there. So the axis of rotation has some inclination with respect to our horizon because of this high latitude. For instance, if I move the position, can I? No, I cannot. Oh, yes, I can. So if I go to 90 degrees, for instance, right, be right there in the top, and I start an animation. So now the axis of rotation seems nicely perpendicular to our horizon because we are all the way to the top. So the display, the way the night sky, and I could add stars, for instance. So I'm adding stars to the night sky, right? So as Earth rotates, the stars themselves are not moving. If I place the sun over here, the sun is not moving, but Earth is the one moving. And because we happen to be on Earth, we experience this movement somehow. So let's go to San Jose latitude 37. Now we have an inclination. Now we experience uh, this, this tilt with respect to our horizon. Okay. Where is, there you go. So in this northern hemisphere, so in addition to Earth rotation, which is daily diurnal motion, Earth also goes around the sun. And that's where we experience seasons. And let me go to another animation that is good to show seasons. There you go. I'm having trouble with this resizing the window here. Well, let's start animation. So Earth has this axis of rotation that is inclined with respect to its orbital plane, and that's what you're seeing here. The sun is over there, and this animation gives this perspective of Earth orbital motion, but also has the perspective of somebody that happened to be um, on a given location, like in San Jose, at certain latitude, and experience right now, in this case, summer solstice, which is going to be tomorrow, by the way. And then, as Earth keeps revolving around the sun, it gets to the point of equinox, right here. That's the equinox, when there is equal illumination in north and southern hemisphere, and then Earth goes to this to the point where its axis of rotation in the northern hemisphere happen to be tilted away from the sun, and then the southern hemisphere observed summer solstice right now, and the northern hemisphere winter solstice, and then apparently we see the sun moving northward, but it's not. It's Earth revolving around the sun. So why is that we experience seasons? Because of this tilt of Earth axis of rotation with respect to the orbital plane. When this axis is tilted towards the sun, like now, the northern hemisphere experiences summer solstice, and the southern hemisphere experience winter solstice at the same time. So north and south have opposite seasons. So here's the extra credit question. Are you ready for which astronomical event, important astronomical event, will happen tomorrow, June 21st, right here, June 21st? What's the name of the important astronomical event that will happen tomorrow, June 21st? Now, why is it that summertime is kind of hot and wintertime is kind of cool? So you can see quite well in this third window down here. So when in the northern hemisphere, the sun is approaching the winter or the summer solstice, and this axis of rotation is tilting towards the sun. So look at this. The light rays, there are two things happening. One, the light rays are hitting the ground uh, with casting less shadows in the floor. In fact, I don't. That's not what I want to see. Yeah, this is going through the entire latitude, altitude, observer latitude. Wait a second. Yeah, 10 degrees north. See if I probably not. But the main point is, in the summer solstice, the sun, the beams, or the solar energy, if you think like a beam of light that hits the ground, it casts less shadow in the floor at noontime, which means more energy is concentrated per square inch of floor, per square inch of area, or per square inch of a surface on Earth, right? In the summer solstice. Now, in the winter, that same beam of energy is spread over larger area. So we have more of that energy spread over large area, which means every single square inch receives less energy, right? So heat has to do with energy accumulated by this surface area. So this is one thing, right? The second thing is the sunlight or the sun is above horizon more hours during summer solstice than in winter solstice. So in the winter solstice, the sun stays a few hours above horizon, uh, and in the summer solstice, it stays much longer. So we have a combination of more light and more concentrated light per square inch, and then that's why summer is hotter than it is in the winter. It's not because of the proximity of the sun, of Earth to the sun, um, in in summer solstice as a result of an elliptical orbit. Okay. So this chapter defines celestial sphere. Celestial sphere, please, does not exist. is a nice invention that was uh, brought about, was was suggested um, in ancient times to explain sky motion. So first, there was some proposal that stars were all of them kind of glued in this celestial sphere, and it's not so difficult to perceive and to embrace this idea. If you go to a quiet place in the night sky without in the nighttime without any sort of a light pollution, and you just stay on the floor looking outside and seeing the dark vault of stars around you, and it's impossible not to think these stars are being kind of glued in some crystalline sphere. That's the idea they had in the past. Now, since we know and we explored this before, that stars are spread out in our Milky Way galaxy, we saw that yesterday, this idea of celestial sphere really is not a good one. But we still use this notion because we see these stars in certain positions, so it's not so much difficult to imagine and to use the notion of celestial sphere to establish positions in regions in the sky. So the stars are not at the same distance from us, they are at a different distance, but we still use this notion of celestial sphere in order to address the fact that we need to locate them in a certain coordinate system. Now, if you take the Earth axis of rotation and extend out to the celestial sphere, you define the north celestial pole, the south celestial pole. If you take the equator and extend out to the celestial sphere, you define the celestial equator as well. Now, uh, in reality, Earth is not in the center of the universe, as we saw, and the stars or these spheres are not revolving around us. In fact, Earth is the one uh, object that goes around the sun in a process we call revolution. So, one thing is Earth rotation, which is spin, Earth's spin that gives rise to day and night. And the other major motion is Earth revolution, which describes the spin of Earth around the sun. So the rotation or the revolution of Earth around the sun. So these two words, revolution and rotation, they have different meaning. Rotation is when a body rotates or spins around an axis that passes through its body, like Earth rotation. And revolution is a spin that occurs by the object around an axis that is not passing through its body. So Earth revolution is around the sun because the center of that rotation is the center of the sun. Not exactly the central part, but pretty much close. So as a result of that, in different months of the year, if you could block out the solar radiation, you would see different constellations in the sky across the sun. For instance, in August, if you could block the sun, you would see Cancer in the sky. So in the following month, in September, again, if you block the sun at night, you would be able to see Leo. Let's take a look at the night sky using our software. Look at beautiful. If you guys go outside now and look south, you might be able to see the moon. Andrew and Christine, do you have a window facing south right now that you can peek? Oh, I think they are sleeping. Oh, they are not. Look at this. Who is not sleeping, my class? Let's see who that is. Oh, Christine. Yeah, Christine is awake. Andrew is completely sleeping. But anyway, so okay. But if you when we finish here, go outside and see if you can take a look in the southern sky. You're gonna see this beautiful first quarter moon in the sky over there, pretty much crossing south. But so let's go to that um, picture here. So in August, right? So in August, if you could block the sun radiation, you would see Cancer in the sky in August. So let's see if this is true. So this is June, July, August. Let's bring the sun. So let's look at the time. That is 12. Oops, 12 p.m. Oh, why is December? I want August. Okay, August. Um, the sun in the sky. So let's get rid of daylight. And which constellations in the sky? Oh, this looks like Leo. Is that correct? Let's see. Option view constellations boundaries, and then let's bring the names. Yeah, looks like Leo. The sun is in Leo in August, right? So let's go back here. So in August, this. Oh, this is wrong. This is wrong. Oh, I have to send. Oh, the ancient thought is constellations. Yeah, this might be true that if you look at the sun in August, you see Cancer. This is not true. This was true. You see this time here? Let's go BC. Oh, not even in BC. In BC, in August. No, let's go to 1000 and something. That's when the astrological system was invented. Oops. 1000 BC. Where's the sun? Oh, the sun is up here. Where's the sun? 7:30 p.m. No, I want to go 12 p.m. Cancer. Yeah, then the sun is in Cancer. So if you go to the time in the past, right, 1000 BC in oh, I mean August. Wait a second, August, July, August. Yeah, the sun is in Virgo. Yeah, so this is wrong. This is wrong. So in August, the sun is either in Leo. So this is not correct. So I have to send my um, some correction to my friend Dr. Fracknoy. See, let's say in June, this graphic is showing the sun seen against Taurus. Let's see if this is true in June. In June is in Taurus, so this is now time 2018. And we are in June, right? So June is against Taurus. This is good. Yeah, it's kind of a close, but yeah, but some of them are not correct. They have to fix that because we don't want to, in the middle of a discussion, find out there is an error and try to figure out what's going on. But anyway, so um, if if we want to check the Earth rotation, for instance, now Earth is rotating, right? And I'm allowing, in fact, it's going fast. Look at this, the time is going fast. So because Earth rotates, we see stars and constellations rise in the eastern sky and setting in the western sky. Let me reduce this, give me headaches. There you go. All right. So this apparent motion is because Earth itself is spinning from the western part of the sky to the eastern part of the sky. Okay. And because Earth does this rotation, then we see the sky itself going the opposite direction from east to west, and we call that this type of motion, apparent motion, diurnal motion or daily motion. Okay. The second motion we are studying now is the one depicted in this animation, is the Earth itself revolving around the sun. And yesterday I was able to show this to you here. So here's Earth spinning in the sky. See, the sun is always here, right? The sun is over here. And so because of this spin, we experience day and night. And in a more complex way, you can see the entire group of four planets, inner planets, Earth, Mercury, Venus, Earth, and Mars going around the sun. And then, so if I stop, so which month is this? March 2008. So if I stop here, I freeze that, right? What is Earth? Earth is right here. Can I bring the labels of the constellation? Let me see if I can. There, there you go. Okay, so this is Leo, this is Virgo, Gemini, Taurus. That's Aries. So the sun, Earth is right here, right? And we are in June. So in June, from Earth, you look towards the sun, you see constellation, put the boundaries too. You see pretty much Gemini in June, which brings the difference between astrology and astronomy. So astrology is a myth, is a mythology or a religion, depending on how you want to call, but has no scientific background because it was pretty much a blend of how the sky looked like when in ancient Mesopotamia or ancient India, and then if you go to a long time of BCE, if you go to BCE, Earth in where I am here in June, right? June at a time that the Mesopotamian were developing astrology about 1000 BC. That's when they invented uh, this complex structure we call astrology. So here's Earth. This is astronomy. This is not astrology. It's astronomy. So you have Earth with the sun in the center of the solar system. So if you look towards the sun, you might be able to see the sun kind of depending on which day June is. Let's say June 30th. So in June 30th, um, the sun, Earth, the sun is visiting Cancer. Like my sister, she is from July 5th, and then people say, "Oh, you are Cancer." So Earth and the sun was seen against Cancer. This is my sister, July 5th. And then it's oh, that's why you are melancholic and you like your home and you like, and then it gives all these characteristics. But see, if you plug the year as it is now in July 1st, right, 2018, Earth and Sun, see that Earth Sun is against Gemini. Gemini has a different characteristic. That's a problem with astrology. So what astrologers do, they do some tricky thing to make the sky appear nicely. Since during daytime you don't see constellations, they keep the position of the sun. um, at, I mean, if you look at the sun in daytime, you don't see constellations, right? But so the astrologers keep the sun's position as it was 1000 BCE. Makes no sense, right? Because no one sees this constellation there. No one has a software like this one, let's say, to verify their creed. Uh, but the planets, you can see them at nighttime, and then you can see which constellations they are visiting. At least if the planets are visible at nighttime. So the astrologers, most of the astrological software that I've seen, um, kind of in a fudgy way, it swap it sent the sun one house apart as you change the sky to 1000 BC, but you keep the planets in the same position because you can see them at night. I know where Jupiter is, right? And I know in the night sky the Jupiter. Let me show you this. Let me go. Jupiter is in the sky now, by the way. Sorry, I'm investing time in astrology because it's a good thing to talk to you about it. How do I do this? Wait a second. I can go here. No, I can go here. Yeah, the full options. Okay, let me change the time to 10 o'clock tonight. So tonight at 10 o'clock, so you look at the sky and then you have beautiful Jupiter. Oh, that's Vega. What is Jupiter? Sorry, I'm taking more time than I thought I would. Oh, almost done here. Uh, so here's the ecliptic, and Jupiter is right here. That's Jupiter right there. So which constellation is Jupiter visiting? So we can bring that label. So you go outside if you know uh, if you know the sky well. Oh no, that one. Sorry. Not illustration. So Jupiter is against Libra. Is that Libra? Uh, okay, Libra. Yeah, Libra. So this is Libra. So Jupiter is in Libra, just to make sure. Yeah, Jupiter is in Libra, right? So you can see, you know, the stars. If you identify night sky well, the sun is not washing out starlight. So you can say that. So they couldn't um, bring Jupiter as it was in BCE in ancient Mesopotamia. So they keep the night sky for the planets as it is, but they swap the sun's position in a crazy way, and they can't explain that. They can't explain. So in a sense, astrology doesn't have a scientific background, doesn't have a scientific basis. Is a creed, is a belief system that has been on for a good 2,000 years at least, or more, 2,000, 3,000 years, and it has different um, interpretations or approach depending on which school you look. And if you go to different cultures, so also it has some small differences in there. Okay. So I will continue with this topic tomorrow. I talk a little bit more about it tomorrow, okay? Because I don't want to keep you too long here. So I will stop taping now, and good night to all of you.